it is. Okay, it's recording. So yeah, let me just dive into it so then I can give James and Mercedes enough time for their interesting findings. So next slide. Yeah, so today's speaker is James the Gregory and Mercedes Rincon from University of Colorado, and they're going to be talking about this interesting topic about pulmonary infections reacting in dormant tumors to the lung. So let's dive into the news. Our papers, which people here are aware of. I guess the most recent paper is this review that was led by Sunny that came out. And again, I've been trying to, as you guys know, we're trying to organize an in-person meeting for summer 2024, talk about regulatory RNA. So University of Malta agreed to host it. So now I'm looking for sponsors. There's a few sponsors here and there coming in, but if you guys have any tips for sponsors and ideas that would be interested in sponsoring, so we can get all the invited speakers we want to get, and then we can make this public and registration, all that, keep the registration fees low. But that's the goal. Tentative date might be a week after this. But if people know sponsors, let me know. All right, so let's go. Just jump in. I'm going to go through this quick, so give James and Mercedes time to give their talk. So recent COVID news. I mean, we missed the last week. I was away, but again, the government has the free home tests. So if people are interested in having received their additional home tests to the holidays, it might be a good idea. There's, as we know, you guys are probably following. There's the JN.1, which I'll go over in 1 second, is the variant that's starting to take over. That's came from the BA 2.86, the variant that was spreading in Europe of concern due to all the mutations it has. And in this paper here, I mean, there is some good news with the variant spreading, is that, if you did get your booster, like this paper showed here from preprint, keep in mind, so take it with a grain of salt. But the preprint showing here that, the booster indeed does seem to, and there's other papers that have come out the past few weeks that do a pretty good job protecting you from severe illness and symptoms to this variant. And this is a post from Eric Topol's Twitter showing the increase that he tagged this person in the Netherlands due to the JN.1. So going to Eric Topol's, back up, there you go. Going to Eric Topol's blog that I once referred to, he talked about a couple of weeks ago about this JN.1 and the mutations. You can see the top row is all the mutations that this has in the spike sequence. It started a few months ago. It's from the EG.5.1 variant, and you can see in Europe this started to dominate pretty prominently a couple of months ago, and now there's more and more wastewater collection data coming out. That's really nice to look at around the world. Like you can see Austria seeing spike in the wastewater cases around the world. One thing that I discovered from this blog post, I know some of you here were involved with our COVID exposure assessment tool that we put out, was about 2 years ago now, that we were using the case numbers. Case numbers become unreliable, and I know Nydia is here. We're talking with Nydia and other folks at Brian Schmoller who created the tool. How do we now get a nice metric for the case numbers? And the tough part was trying to translate wastewater number to actual cases. And this person here is a COVID forecaster, modeler, Jay Wieland. He actually has done this. So we decided to circle back with Nydia and Brian, maybe to figure out how to incorporate this with our COVID exposure assessment tool. Now the wastewater numbers, he's done a pretty good job for estimates. But the estimates here, you can see, due to his wastewater, that he's estimating about 720,000 daily infections are happening, which of course is not reported because due to the lack of reporting, but the wastewater is indicating that based on his model forecasts, which is probably not that surprising if you hear about how many people getting infected. But the good news is that, again, the boosters, this is a couple of papers that we went over a few weeks ago, do a good job. Both the Moderna booster and the Pfizer do a really good job of protecting you from severe illness and recognition of antibodies. And some other good news is that these other new vaccines, nasal vaccines. There's one nasal vaccine that has been in study and in clinical trials for a while now, has been showing pretty promising results down here, saying single dose. This is the plot from that, how you can see the obvious thing with and without the vaccine from people who prior no COVID infections of health workers, what improvement it has. There's this other one that just came out a couple of days ago in Nature talking about this dry powder aerosol, which I've never heard of until now, but it's extremely promising. And supposedly it's going to give you a robust production of your IgG, IgA antibodies to protect you in a T cell response. Unfortunately, this paper is behind a firewall, so if people have access to their journals, hopefully you'll be able to read it. But this is the idea. It's like basically a dry, inhalable powder. You don't have to keep it in storage. You keep it at room temperature, and then targets what it needs to do for the virus. So these are some promising good news for better and easier accessible vaccines other than the shots. On that note, talking about vaccines, this paper came out a couple of weeks ago, talking about how repeated mRNA vaccines can actually boost your T cell responses in people and recognition from previous COVID infections. So this was interesting that basically saying the more times you get vaccine, the more your T cell CD8 positive T cells gets boosted. So that's actually a positive note too. Maybe by less and less people have severe impact of the virus these days. And then this paper just came out a couple of weeks ago, or a week and a half ago, where it was talking about, again, it has some, actually, a reason I bring this paper up, so usually I try to find papers that might have good RNA-seq data or single-cell RNA-seq data we can mine. This has it. But the part about this paper is talking about how the SARS-CoV-2 vaccine enhances your memory of your T cells induced, again, kind of confirming, it complements this paper here too. This was an interesting case study that came out this past week, kind of showing that, because the question is the virus replicating, can replicate in the blood? And indeed, in this one case report, they saw that this virus is actually being detected in the blood and being replicative competent, which is kind of surprising. Well, not surprising, but not really shown before. And I'm going through this quick, so if anyone has any questions, just jump in quickly. But some long COVID news. I know with some folks in our group, like Rob Schwartz and others, we've always thought about, since we know there's long COVID, is there such thing as a long flu? And people haven't paid attention to it. And people have been trying to study this. And you might be familiar this one paper here that came out from Ziad Al-Ali's group. He's done a lot of good work with long COVID. People are probably familiar with his papers, but he basically did a comparative study looking at long COVID versus COVID versus seasonal flu and the long-term outcomes. And what he basically saw, of course, long COVID, you're going to have more fatalities and deaths and severe impact. This is one of the plots from this showing that throughout this paper, showing that basically, with COVID, you got 50% higher death rates and a lot more longer impact. But the interesting thing was that seasonal flu seems to be causing similar type long, COVID or long flu impact, but in a lot lower population of people. So that was actually a pretty neat thing. There's no biology. It was just purely just looking at a veteran population. This is what the data was, like 81,000 records, and going through, records and just quantifying what people have said after long-term impact, 18 months after infection from both. So there could be a long flu. What is the mechanism behind it? Don't know. Just because, and long COVID, we don't know the mechanism, but there's a lot more data out coming for that. And this preprint came out looking at basically long COVID associated with cognitive issues. And what this paper had done was basically look at this population of post-COVID condition, long COVID patients, and then did a bunch of type of memory tests, response tests, and so on. And then basically, and then looked at the acute population to compare, what types of things that they might be impacted cognitively, for example, slow reaction time, recognition for vigilance tests, and so on. Which might not be so surprising to people here because we know of all the genetic or impact on the pathways and things that could happen, let's say, to the mitochondria long COVID. And then this last paper was talking about, this came out actually a month ago, but I missed it. So it's about genetic factors for fatigue and dominant long COVID. And they looked at the UK population. This is the abstract from there. But one of the things they talked about is they identified several SNPs and several single nucleotide variations or polymorphisms, and then also identified several genes through their algorithms that they're trying to figure out what was there. One was TLF4, which is down here. They said could be an antagonist and a possible candidate for a biomarker or a therapeutic target for long COVID. And then basically they identified a bunch of other genes. They did talk about mitochondria here as a potential marker, because there were some genes in here that was related to mitochondria that some people here might recognize. So again, the dominant variants is the HV.1, but JN.1's taken over. As we already went over in the wastewater, you see the increase in the U.S. That also is showed earlier around the world. This is the biobot that we're familiar with. The dominant variant, what seems like EG.5, which is the JN. They don't specify the details of what's variant from EG.5, but JN.1 would be that case. I was due Middlesex County, where I live. There was a bigger spike than the national average going up, but now it's coming back down. Maybe probably go back up during the holidays. And I mentioned this a couple of weeks ago. CDC has revamped their wastewater site, made it a lot better, a lot more detail on here, so you can go here and look at all the details related to the region and what changes are for very high risk versus minimal risk. But most places here seem to be higher risk for wastewater data. And then, as I said, the variants that are dominant is JN.1, but this HV.1 was coming in, but again, JN.1 is outcompeting. EG.5 is, from, where is it? EG.5 is from one of the XBBs. JN.1 is from the BA2.86. HV.1 is the EG.5, sorry. So that these two are kind of related, as you can see. And then globally, of course, this site doesn't really report case numbers, but you can see hospitalizations go up. So I went through this really quick, but I'll share the slides and all the papers that that were in here. I don't know if there's any questions, but I guess you could digest this later. But okay, so I'm going to turn it over because you've heard me talk enough. But the key part is now we want to hear James and Mercedes talk about this really fascinating work that they've unpublished data, and we're going to be collaborating. So everyone here should probably want to collaborate with you guys to help push this data forward, because I think this could have a huge clinical implications for the future if it is true, and I think it might be. Okay, so let me stop sharing.